Hello and welcome to Horizontal Construction, Equipment History, and Economics. In this presentation, we're going to be covering major equipment inventions, uses of equipment throughout history, and then major equipment developments. Then we'll finish off with a couple of things that you should consider when purchasing your next piece of equipment. So, without further ado, let's go ahead and get started. Some major vertical construction projects that were completed in Boston include the Prudential Center. This building is 52 floors, 759 feet high, and was completed in 1964 by Luckman and Associate Architects. The John Hancock Building, 60 stories high, 790 feet, completed in 1976 by Henry Cobb of I.M. Pei and Partners. And lastly, the Federal Reserve Building, completed by Hugh Stubbins, the architect. This building was completed in 1977 and is 604 feet high, 33 floors. Now, some major horizontal construction projects that took place in Boston include the Big Dig, officially known as the Central Artery and Third Harbor Tunnel Project. This was led by the joint venture of Bechtel with Parsons and Brinkerhoff. There was also the Fast 14. This was done by J.F. White Contracting Company. This was the replacement of 14 bridges along Interstate 93 over 15 weekends. And lastly, there was also the Route 3 reconstruction project, which was led by Rhodes Construction Contracting. Now, a big difference between horizontal and vertical construction is not just that one is horizontal and one is vertical. Vertical construction is typically led by an architect, while horizontal construction is typically led by engineering firms. The lead on these projects is intentional, and it has all to do with the planning of the construction project. Now, construction planning has been around a long time. Well, probably just about as long as and perhaps Fred was trying to earn money for his family and for bowling.
Step aside, Pagliacci, whilst the captain warms up.
It's probably fairly safe to assume that most cavemen were constructing to protect themselves from the environment and not for a profit. Today, though construction workers are not 100% safe from their environment, efforts are made to protect them on the job site. But the reality is a driving force behind every construction company, in fact, the driving force, is to make a profit. Over the past 50 years or so, construction companies have been looking for ways to complete projects as quickly and as safely as possible. Delivery methods have changed from design bid build to design build, construction management, and integrated project delivery methods, where the best of other delivery methods are customized to achieve a specific goal. The goal of speed in a construction project consists of a realistic schedule, which would include simultaneous activities, but also includes an analysis of the equipment required to complete all the activities on a specific project. This means that a strong knowledge of business and the business of equipment is required. Equipment means money, and money means equipment. This also means that to be successful in the construction industry, one must have a knowledge of when to buy equipment and when to rent equipment. They must also have a knowledge of how to maximize equipment efficiency, and probably most important, an understanding of what equipment is necessary for a particular job. Now, this last item may sound like common sense, but backup plans are necessary. When you're headed to the job site for excavation, you should make sure you know whether you're dealing with soil or dealing with rock. As an example, one of the biggest change orders on Boston's Big Dig project was the misunderstanding of a soil profile. Though the project was an overall success, this misunderstanding was quite costly. Another successful project was the Yerba Buena Island Viaduct Reconstruction Project in 2007. This roadway connects Interstate 82 with the east span of the San Francisco-Oakland Bay Bridge and then connects with the tunnel. Approximately 350 feet of this roadway needed to be replaced. However, it would have been very difficult to shut down the traffic on this extremely critical passageway. Therefore, the contractor built the replacement structure right next to the old structure. Then the contractor demolished 6,500 tons of the old structure on site in less than 2 days. Then the new roadway was lifted and put into place. The roadway was down for less than 2 days and was back in place 11 hours ahead of schedule. Another successful project in Massachusetts was the Fast 14. Here, again, 14 bridges were replaced over 15 weekends, one bridge every weekend with no construction taking place over the July 4th weekend. Much of each bridge was constructed off-site, prefabricated. Then partial lane closures took place at 6 p.m. on Friday. The bridges were destroyed and replaced by 6 a.m. Monday morning. In both of those cases, state-of-the-art processes and equipment were used. It has long been proven that older equipment simply cannot compete with newer equipment. Newer equipment costs less to maintain and has much higher production rates. But a single piece of new equipment is not going to make an enormous impact on a project if it's working with a bunch of pieces of older equipment. Most projects require multiple pieces of equipment that are going to be working together. This is referred to as the equipment spread. Understanding the equipment spread will give a contractor a competitive advantage when bidding on particular projects. Also, maintaining proper records and operating expenses will assist those individuals who are working in large corporations in monetizing their requests for new equipment. So with this introduction, let's now go ahead and take a look at equipment history. So it was not that long ago that construction began on the Suez Canal, 1859. When the Suez Canal began construction, it was being dug by laborers. It was the muscle of humans that was moving the materials. In this case, these laborers were provided by the Egyptian government. They were called corvée laborers, essentially unpaid labor. But everywhere and everyone, especially the laborers, were trying to think of a better way to excavate. Though there were a couple of pieces of machinery on the Suez Canal for the first few years, by 1864 Ferdinand de Lesseps began to try hauling some of this material with machines. Soon there were over 300 pieces of equipment at work on the Suez Canal. These machines over the next 3 years excavated the majority of the 100 million cubic yards of material from the Suez Canal project. In fact, wherever there was construction, there were people trying to think of better ways to accomplish it. Visionaries want to reduce the amount of physical labor required while increasing productivity through the use of machines. One of the biggest challenges on any construction site is the transport or the moving of heavy materials. Now, going all the way back to 1420, a Venetian by the name of Giovanni Fontana began sketching such equipment, and Leonardo da Vinci actually drew a diagram of dredging equipment in 1503. and at least one of those sketches was turned into a piece of equipment, though at the time a power source was not available. But progress was slow. It wasn't until 1817 when ground was finally broken on the Erie Canal. The Erie Canal was 350 miles long and it was excavated largely by human labor. At that time, mostly Irish immigrants. Here again, it was human muscle that did the majority of the work. But soon, waterways would no longer be the way to travel. Instead, locomotives were starting to come to life. In the mid-1830s, the Boston to Lowell Railroad was open for service. However, even this railroad was built largely by physical labor, but all of that was about to change. In 1837, on another railroad project in Massachusetts, the first steam-powered excavating shovel was put to use. It was called the Yankee Geologist and was invented by William S. Otis, a civil engineer working for the Carmichael and Fairbanks Company. The need for more power and more economical machines continued to drive growth in America. The biggest driver of this growth was in fact the railroad. From the mid-1880s to the mid-1890s, over 70,000 miles of railroad track was laid down in the United States. In fact, the very reason that William Otis created the Yankee Geologist was because Carmichael and Fairbanks were in the business of constructing railroads. Not to mention the fact that he wanted to impress his uncle, Daniel Carmichael, co-owner of the company. Right around the same time, in 1890, Nicholas Otto patented a four-cycle gasoline-powered engine. However, the courts in Europe felt that this patent was far too valuable to limit to one company and removed the patent. With the patent now removed, many companies began to experiment and work with gasoline-powered engines. One of the companies that mastered this was called the Best Manufacturing Company of the United States, and they demonstrated and introduced the gasoline-powered tractor in 1893. Best Manufacturing later merged with another company and became Caterpillar. Then, in the early 1900s, Plessy C. L. Cummins develops the Cummins diesel engine. This engine soon replaced steam boiler shovels for excavation with diesel-powered excavation. And all of this leads back to construction because one gentleman, Warren Bechtel, masters the use of these engines and their applications to build a successful construction business focused on infrastructure projects. To this day, the name Bechtel is synonymous with successful infrastructure projects throughout the world. These types of large construction projects are not only a good place to try out new, innovative construction techniques, but they're also a great place to experiment with new pieces of equipment. And no one knew this better than Benjamin Holt. In 1908, William Mulholland, the city engineer for Los Angeles, began construction on the Los Angeles Aqueduct. The aqueduct stretches almost 250 miles from the Owens River to Los Angeles. In between, it must cross mountains as well as the Mojave Desert. The Holt Manufacturing Company had sold some equipment to the city of Los Angeles for this project, and therefore Benjamin Holt decided to use this project as his own laboratory. Here he found that cast iron gears would wear out quickly from abrasion, so he began to manufacture his gears from steel. Holt also found that his two-speed transmission system could not go low enough for the climbing that was required on this project. Therefore, Holt began to make modifications to his tractors to compensate for this deficiency. When the project was over, city engineer Mulholland said the only poor purchases that he made during the project were those that he made from the Holt Manufacturing Company. But Benjamin Holt was a forward thinker who felt that the project was a huge success and a positive experience, as he had learned so much about his equipment. Earlier in this presentation, we said that Best Manufacturing merged with another company to become Caterpillar. That other company was, in fact, Holt Manufacturing. Another great project which produced many equipment innovations was the Boulder Dam, more famously known as the Hoover Dam. Bolted connections between pieces of equipment ceased to exist after this project, as it was discovered that welded equipment and cable-operated attachments served the industry much better. Other accomplishments on this project included aggregate production plants, improvements in concrete production and concrete placement, and the use of long-run conveyor systems. The Hoover Dam was one of very few projects that actually took place during the Great Depression. And just before the Great Depression, there was another major change that was about to take place in transportation in the United States. And after World War II, this transportation change was well ingrained into the hearts and souls of America. And now President Eisenhower, who 30 years earlier was a young Army officer with the Corps of Engineers, saw this change coming and was ready for it. President Eisenhower instituted the Interstate Highway Transportation Program, and construction in the United States greatly accelerated. This acceleration could not have been possible without major advancements in machinery. Some of the major developments which increased the control and the productivity of machinery included high-strength steel, nylon cord tires, the torque converter, as well as high-output diesel engines. The yield strength of steel through production innovations increased from 30,000 psi to 45,000 psi. This means that the steel was proportionally better as far as fatigue properties goes, which means machines had greatly reduced their overall weight. As an example, a 25,000-pound truck now only weighed 16,000 pounds, giving it an increase in efficiency and speed. With the introduction of nylon cord tires, load capacities increased and larger tires were now possible. Furthermore, heat resistance became a practical reality. Tires were now able to operate in a cooler environment and achieve better traction. This improved machine productivity. Nylon permitted the number of plies in the tire to be reduced by as much as 30%. Now, with the power shift transmission and the torque converter, the front-end loader is now replacing the old dipper stick shovels. Concrete is now the building material of choice in America. It has moved from a manually operated system to a hydraulically operated complete operation which is electrically controlled. The amount of concrete being produced increases tenfold as the focus turns to delivery and placement as opposed to production. Engine manufacturers found new ways to get greater horsepower from every cubic inch of engine displacement. Compression ratios and engine speeds were raised tremendously while turbocharging was perfected. Now today, some may say that there are no new radical ideas as far as machinery goes, but innovation and operation are constantly being perfected by manufacturers. As an example, new attachments for current equipment is constantly increasing productivity. Control of the machine is now possible without a human in the machine. The energy and the strength of the machine, though using past principles, is being amplified, and computers are constantly gathering and processing information from the machine to increase efficiency. Looking ahead, there is definitely a trend in the industry where contractors would like to have a hub machine, which is essentially only a mobile counterweight with hydraulic power. Attachments could be used to handle many different tasks. In a very real sense, this is already happening. Hydraulic excavators have many different attachments, including compactors, shears, hammers, and forks, Loaders have forks, stingers, and even brooms, so the contractors can maximize their investment. Another major advancement for construction machinery is safety. As machine control improves, so does control technology. In the engineering world, many people are beginning to look at geospatial engineering, and with new GPS guidance systems, it's probably only a matter of time before machines can be run completely from the desktop. There may even be a day when you can program your machine to do all of the required work. The machine would know when the weather is going to be bad, when the weather is going to be good, and could maintain soil samples to know exactly what type of material it's going to be dealing with. But these machines are in the future, and today we must understand the value of every machine that we buy. Which leads us to our final segment on owner and operator costs. Here we're going to go through some basic interest calculations and apply them to purchasing equipment and renting equipment. As a quick example, if you were going to be renting a dozer and the dozer is going to cost you $180 an hour, but you know that the dozer can move 250 cubic yards of material per hour, you could do a quick calculation and understand that your costs are going to be 72 cents per cubic yard, and you could set your price from there. Of course, this is a single price and a single cost. Imagine if this project is going to go on for months or perhaps even years. This means that you would have to have a concept of the value of money. So let's assume that you borrowed $2,500 and you're going to have that $2,500 for 1 year, and the annual interest rate on that $2,500 is going to be 5%. Well, when you go to pay it back, you're going to pay $2,625. But for the sake of this discussion, let's assume that we don't pay the money back. So now we're going to get charged another 5%. Not on the $2,500, but on the $2,625 that is owed. Therefore, when we compound this interest, we now have to pay back $2,756.25. Now this can also be written as an equation. So here, F is the future value of money, and it equals P, the present value of money, multiplied by 1 plus the interest rate, and N represents the number of periods or payments that you'll be making on that loan. So if we use this equation for our example, we're going to get the same $2,756.25 that we got previously. So now let's take this equation and put it to a real-world example. A contractor has an opportunity to do a project that's going to pay him $180,000. He needs $150,000 up front to hold him over for the 4 months that the project is going to run. He finds someone that's going to back him the $150,000, but the person wants 5.25% back at the end of 1 month, or he's going to compound the interest every month until he gets paid back. Now the contractor knows that he's not going to pay the person back until the project ends, which is going to be 4 months later. Should this contractor do the job? If you can, pause the video and check out the numbers on the next slide. So here again, if we just simply plug in our numbers using our equation, F, the future value of money, equals P multiplied by 1 plus the interest rate to N, the number of payments, which we know now is going to be 4, the 4 months that he's not going to pay back. He's going to wind up paying back $184,068.59, meaning he's going to be in the hole $4,068.59. He absolutely positively should not take the job. Unless he decides that he can pay him back. Now, if he does pay him back the money in one payment in 1 month, he's going to pay him back $157,875, meaning that at the end of the 4 months, he'll have a profit of $22,125, all because he paid back his loan on time. So let's take a look at another one. Let's assume that a contractor is doing well and he sees a project that's going to be up for bid in 18 months. To get the job, he needs to buy a piece of equipment that's going to cost $250,000. He wants to save now. He finds a bank that's going to give him 3% compounded interest every 6 months. How much money would the contractor have to put away today to have the $250,000 necessary to buy the piece of equipment in 18 months? So here we can use the same equation, but we are going to algebraically solve for P. And what we're trying to find out now is how much money do we have to have today, presently, to have $250,000 in the future. And if we use this equation, then just simply go ahead and plug in our numbers, we will see that we're going to need to put away $228,785.41 today to have $250,000 in 18 months. And again, the $250,000 up top is what we hope to have in the future. Down below we have 1 plus the interest rate, and the 3 is the number of compounded interest payments we're going to be receiving from the bank, 1 every 6 months over the next 18 months. And again, these are just simple equations that you can use whenever you're going to buy or rent a piece of equipment. But typically, if you're going to buy a piece of equipment, you're going to have monthly payments. So let's take a look at just one more, and this is uniform end of period payments for when the end periods are going to continue over the course of a loan. So here is the equation, and again, A is the uniform payment that you would be making monthly on a particular loan. P is the principal of the loan, and I is the interest rate on the loan. And again, let's go ahead and apply this to an equipment example. Let's say a contractor buys a truck for $30,000. She puts down $5,000 and she has an interest rate of 6% and a 5-year loan. What is the monthly payment going to be on this truck? So in this type of an equation, the interest rate again is an annual rate, but it has to be spread out over the number of months in a year because you're going to be making monthly payments. So we have 0.06 divided by 12 is 0.005, which means that anywhere in this equation where you see the I, we're going to replace it with 0.005. The 60 comes from the number of payments that will be required on the truck loan. So if we go ahead and plug in our numbers, we should come up to a monthly payment of $483.25. And ladies and gentlemen, this is going to conclude horizontal construction, equipment history, and economics.